Hey everybody, we're going to take another look at sine and cosine graphs and just talk about some more of their properties that we didn't touch on all the way last time. So when we graph sine and cosine, we'll start with our five key x values, which would be all of your quadrantal values on your unit circle. And filling in the y's, at sine we start at 0 degrees and 0, and then at 90 degrees I've gone up to 1, at 180 back down to 0, 270, -1, and 360 back to 0. Now if I plot those on my graph here, one of the things to make sure that you try and do, which is fairly hard, is that you want to make sure that you've got some nice curves to these graphs, as opposed to drawing just like some zigzags up and down. And it's just a skill that we develop over time, and I will extend that in both directions. Alright, so I've got my sine graph right here. Now I'd like to go through all these questions that they have for us. It says, first off, what is the domain of a sine function? Well, domain is our x values. And because this function will go left and right forever, our domain is going to be all real numbers. What is the maximum y value? Well, the maximum y value that we have is going to be +1. And again, this is for our parent function. Minimum value for y will be down to -1. And the range of the sine function, well, my minimum y and maximum y are -1 and 1, and those will be the values that my function goes between. So I will say that my range is, we'll write our range as an inequality. I'll say -1 is less than or equal to y, which is less than or equal to +1. So again, writing that as a compound inequality. It says sine is a periodic function because its y values repeat. What is the period of the sine function? Well, the period would be essentially like the length of x values that I have to travel until my y values do start to repeat in the same pattern that they were before. And so while I travel 180 degrees to get back to 0, I still have to go the full 360 until I would start to mimic this path once more. So my period is going to be 360. The x-intercepts, or zeros, well, there's actually going to be an infinite amount. And so I could just list out the three that I have here. The x-intercepts that I have are 0, 0. I also have 180, 0, and I also have 360, 0. But that could be quite an extensive process. So what we could say for our x-intercepts is that all of those x values will equal, let's say, k times 180. And what we want to do is just define that k is an integer. So this is like a little mathematical way of saying, every multiple of 180 degrees. All right. Now, what is the y-intercept? Well, there is only one of those. If I had multiple y-intercepts, it would fail the vertical line test, and it wouldn't be a function. My y-intercept is going to be at 0, 0, at the origin. All right. Now let's take a look at cosine. So with cosine, we want to use the same 5 x values here, 0, 90, 180, 270, 360. But this time I'm starting at +1 for my y value. Then I go back down to 0, and then I will go all the way down to -1, back up to 0, and then finish where I started. So I start at 0, 1, head on down, and then 180, -1, 270, 0, and 360, 1. So I'm going to connect this. Nice curve, and I will extend on both sides with some arrows because it will continue. The domain of the cosine function is going to be identical to sine. It is going to be all real numbers. The maximum y value is the same. Maximum y value is +1. The minimum is the same, also at -1. The range of the cosine function is also the same. where my values range between -1 and 1. And it says cosine is a periodic function because its y values repeat. What is the period of the cosine function? Well, the period is the same, 360. Really, the only difference between our sine and cosine function is that, if I were to, again, pick this up and drag it over here, it's just shifted slightly to the side, a horizontal shift, if we want to be proper. The x-intercepts, or zeros, so listing the two that I have here, I would have 90, 0, and then I would also have 270, 0. And now we could generalize this like we did before. I could say that I will have x-intercepts at every x value, but this time I need to shift it over. So I'll say 90 plus k times 180. So essentially I've got every 180 degree multiple, but now I just started at 90. So if I add 180 degrees to 90, that'll send me here. If I were to subtract it or put in a -1 there, that would send me down over here to -90, 0, where the next one would be to the left. And we just want to also say that k is an integer. And then what is the y-intercept? Well, the y-intercept would be at 0, 1. All right. Thanks, everybody.